I love the enthusiasm you'll have.
How does that mountain do it?
It's amazing.
What are the landforms associated with the three-plate boundaries? Who's got one of them? Tell me the boundary and the landform. Or you can tell me what you want, Sydney. Go ahead. And it doesn't have to be all that. We'll put both. How about? Is that okay? Volcanoes and mountains. The one that I had in my head that I was thinking was mountains, but absolutely volcanoes can be created at convergent boundaries. That's not the only place, but that is absolutely true. All right, we're going to go here and then here because there are three of them, so that'll get, yeah.
The divergent one, and it creates the Rift Valley.
Tough.
So what is it? What'd you say?
Like the Rift Valley.
Rift valleys. Awesome. All right. Colin, you had your hand up a second ago. Do you want to put your hand up still or no?
You know what? I will.
Go for it.
For the transforms, we had a transform balls.
Good job.
Atta baby. You bet.
All right.
Yeah.
And because we remember that a week from today, we're going to have the opportunity, gentlemen, thank you. Shh. We're going to have the opportunity to take a test over this. We need to make sure that we know it, we understand it, we've not forgotten, and we haven't, we're not going to lose it. Can you also draw some arrows for me to show which direction these plates are going to go relative to one another in a convergent versus in a divergent versus in a transform, just to remind yourself? Question or answer? Answer. Okay, hold on just a second. I want to give everybody a second to draw them. Is that okay? And then after that, Haley, you are all over it. I love it. Like doing like a dance. Could totally make up a little it could be the next big thing, David.
No.
You don't think so? I mean, you have to have the right mindset. Got to sell it. I think you could totally do it. All right, Miss Haley, which one you got? The two arrows go in like this, right? We talked about this a few days ago. You did this yesterday with the sand, right? The sand was your land and you pushed those plates together, convergent boundary, and you found the mountains. How about for the divergent? What direction do those plates go? What new faces, new hands in the air. Y'all know this. Come on now. Come on, Elena, what you got? They go away from each other, right? To diverge means that you're going apart. Absolutely. Can use some technical. Yes. Only kindness.
Good job.
Only kindness.
Kindness.
All right. And then transform boundary. Talk to me about the transform boundary. Maddie, what you going to say about transform boundary? What? I know it's mean, right? You got this. They go past each other. Right? Draw the picture if you haven't done so already. Issues, questions, or concerns about this, friends? No. Fantastic. All right. Next thing we're going to do, since you already have that sandbox earth sheet out, maybe, and if you don't pull it out, there was a part of, hold on just a second. There was a part of sandbox earth that said, wait, don't write anything for now. Right? Do you remember that? Yeah. You filled in this box here, this student idea box. And then there was a forces box that said, don't write anything there. We will right now. Here it comes. Now, Colin, you had a question. What's up, friend?
Well, I just want to say that we should follow the motto, ELE, everybody love everybody.
That's lovely. I like it. All right. So just to make sure that this activity in this piece of paper is a complete understanding, really quickly for me, since this says pushing the land together, what kind of boundary is this that you were creating there? What is it? Convergent, part 1. So go ahead and write that down if you haven't done so already, just so that you know for sure when you're studying this weekend or early next week that you know that pushing the land together is convergent. The more times you write it, the better it sticks. Right? You have to write things down at least 3 times for them to actually stick in your brain. It's true. They've done research. All right. So when you did this, you found that you got some mountains, blah, blah, blah. The force that is associated with this is like the technical term force, is called a compressional force. perhaps you have a concept of what to compress means, right? It means to kind of push together. Okay, so that's what we're talking about, and that's the only like piece of technicality that I want to make sure that you have there. Okay. For part 2, that's pulling the land apart. What kind of boundary was that? Divergent. Look at us. Look at us and our great vocabulary that we have here. That's the one where we created a trench, right? You had that rift valley. The force that's associated with that. Do you know what it's called when you have like a string and you're playing tug of war or something? Do you know what that's called in the string? It starts with a T. Tension. And that's exactly what we call this as well. The force that's associated with this is called a tensional force. Tensional. It's a tensional force. That's when you're pulling things apart. Okay? So you can think about that again, kind of like a tug of war. If you want something to kind of help you remind you what that is. Okay, and I'm just going to write down with compressional force, that's like pushing it together. The last one has kind of a funny name. First of all, what type of boundary are we talking about in that one? What? Transform. So that's a transform boundary. And the force associated with that, the name of it is a shearing force. How are we going to remember that? Shearing? Oops, my handwriting is kind of terrible there. Let me write it again for you. Have you ever heard of the word to shear before, that verb? What's that? What do you think of?
I'm good.
I'll tell you what he said.
He
He
said,
said that you do it to sheep in Minecraft.
I was about to say, man,
I was going to say to sheep. Like, that's what was in my head. Right? When you shear a sheep. So if that makes sense to you, what does it mean to shear a sheep? To shave them, right? So if you've ever watched a sheep be sheared, or if you've ever like seen shaving it, right? Like you've got the shaver and it goes like this, right? Which is exactly what happens in a transform boundary. So they're moving in opposite directions. That's exactly what's going on. So they're going, yes, yep. So you can think about like literally shaving a sheep. If that helps you to remember it, by all means, my friends, whatever works.
I'll write down mine.
Okay. How we doing, team? We good? All right, we're going to look at our list of things to do again. So we did this one. Now we're going to do a quick jigsaw. Well, it's not really a jigsaw. It's more of a divide and conquer sort of thing. So the intention with the assignment that was written that had the video on the front, then there were like 8 pages of reading to do on the back and reading and answering questions. And I was thinking about that. I'm like, that doesn't sound like a whole, I mean, like, not that it's bad to read. I want to make that clear. But can we make that a little bit more efficient? And so this is what I've done to hopefully make that more efficient. Is that instead of you having, like each of you having to read all of the pages, I'm going to have groups of you read read a little bit and then put it together so that we can put it all together in notes. Does that sound okay? So we're going to kind of divide and conquer. So what we're going to do, I'm going to need 5 groups. So we're going to count off by 5 today. I think this will be great. And Jack, you seem super excited about counting off by 5. So I'm going to let you be number 1. Number 1, we'll go here.
2, 3, 4. 1, 2.
Make you a 3.
1, 2, 3, 4, 5.
Angel, you can be a 3, 4, 5. 1, 2, 3. Okay, so what I want you to do first is to move to your spot with your table. So let's do 1s here. We'll do 2s at that table there. 3s here. 4s at that table, and 5s. So you will probably need a computer, and that's probably it. Just a computer. 1, 2, few, a couple. 3, 2, I don't know, something like that.
You're standing trays. Where the ones at?
Right here.
Yeah, I know. She went sideways.
Okay. So you do not, I don't want you to like get in there too far yet. I want you to listen up here really quickly. Let me give you the instructions first. I don't want this to take more than, I don't know, 15 minutes max. Does that sound okay? Sound doable? So 15 minutes maximum. Let me tell you what the plan is going to be. So there is a reading, and I'll show you where it is on Canvas in just a minute, but I want your eyes up here. Your phones are absolutely away. Your computers are just kind of like not bothering you right now because I just want to show you this. So I have a few textbooks right behind Nicholas. There are a couple. Angel's got one right next to him. I've got one up here too. So if you'd like to read this, you know, with a book in front of your face, you're welcome to. Otherwise, it's up here. I want to go through this just really quickly because there are going to be certain things that you're going to look for. So you got convergent boundary mountains, blah, blah, blah. Group 1, so you might want to write this down or type this out somewhere. Group 1, you are in charge of oceanic convergent. Okay, it's the first one that you see. Okay. Group 2, you guys are in charge of oceanic continental convergence. Group 3 is going to be in charge of continental convergence. That's you guys, right? Group 4 is in charge of divergent, and group 5 is in charge of non-boundary. Okay? So just remember that. Let me show you where that you can find this and what you're going to do with this information. So on Canvas, that reading is there at the bottom in the unit that we're in, unit 4, at the bottom. So there is a thing that says mountain building reading. And then right below it, it says period 1, that's you all, mountain building slides. If you click on that one, you should have access. If I've messed it up, you're going to let me know. And in that, you'll see that there are 5 slides, one for each group, right? Get this? Okay. And each of them is labeled. Boop, boop, boop. So you guys are oceanic, etc. So you need to tell me what is the type of boundary. You need to tell me what kinds of mountains are formed, and I want to know of an example on Earth. Okay? Listen. Then I need you to get me 2 pictures. Google image search is totally fine as long as you're searching for the right thing. So you need to read first and then search. And the thing that you're going to look for 2 things. One is an example on Earth. So one of the mountains that one of your groups is going to do are the Hawaiian Islands, okay? So you could find a picture of the Hawaiian Islands and put them here, or the Himalayas, or the Rocky Mountains, or the whatever. You're going to find a picture to put here. And then where it says diagram of plate interaction, they have great pictures in the reading. So you could copy and paste those, I guess. Or if you go to Google and type in continental oceanic convergent, oh my gosh, they're all there, right? Throw one of those in so that we can use that. Is this doable? Can you handle it? All right. I'm going to give you 10 minutes and I'm going to check in with you. Work with your group. This is a group effort. Talk together. Make it happen, you guys. Go, go, go. You have a chart in front of you. Momentarily, you will be responsible now for all of the types of mountains, not just the ones that you just read about, but all of them. So thank you to your classmates for helping you out. So take a look at your blue sheet. Oh my gosh, everybody's going to have that wonderful feeling of ownership, aren't you? Yeah. Yay, look at us and our ownership of our learning. How beautiful is that? All right. So the very first one, the very first row here, under plate interaction, you're going to write down oceanic. Okay? Our friends that were group 1 learned that was a convergent plate boundary. Again, that means that the plates are coming together. These are plates that are under the what?
Water.
Ocean, under the water. We just want to make sure that really makes sense. coming together. And what does that cause? What does that make? It makes some volcanic islands, volcanic mountains, things like this. They're so pretty. So on your chart, under type of mountains, you're going to write volcanic island. That fourth column over, that's the trickiest one, friends, because what I want you to do, it does not have to be super artistic, but what I want you to do is to draw a picture to show the plate interaction. So you want to draw something that looks like this in that spot that says picture, okay? It doesn't have to be perfect. Let me show you how I drew it when I was taking these notes before. I'm going to show you, so listen. I drew one plate like this. I drew another plate like this. And then I drew water over the whole thing, okay? And then I drew magma coming up from the mantle and making mountains. Okay, does that make sense? It does not have to be beautiful. But the things that I want you to know are that there are two plates that are converging. It's a convergent boundary. You can even draw those arrows. Okay? It's all underwater. And as a result of that subduction means that one goes under the other. Magma is brought up from the mantle and creates the volcano. The volcano creates the mountain. How's our artistic endeavor going? We doing okay? Okay. Again, it does not have to be perfect. A friendly reminder as you're studying for the test that's coming up next week, you have access to this because I'm going to leave this on Canvas. So if you want to go back and look at this again, you are super welcome to do that. Okay? You're welcome. And then, for example, the island of Java and the island of Sumatra in the Indian Ocean, okay, kind of near the Philippines, the Philippine Islands, so down south of Asia, kind of in between there, is an example of oceanic convergent boundaries. There's a beautiful picture of Java. Not a bad place to spend a cold winter day, to imagine. Are we good? Can we keep cruising?
Yeah.
All right. Round 2. Oops, let me erase my mess here. Under plate interaction, that's the second column. You can write down oceanic continental plate interaction. It also occurs at a convergent boundary. Do you notice how that boundary column goes really long for those first 3? It's because they're all the same. Okay? So on the boundary column, for all 3 of those, it's all convergent. We kind of did that on purpose. Woohoo! So you've got oceanic continental. This is one that kind of looks like what we saw yesterday. Well, I guess the one we saw yesterday was a little bit different. But anyway, it produces folded mountains and volcanic mountains. This one is like super powerful and super interesting. I don't know if you remember when you were looking at the big maps a few days ago, when you looked at the side of South America, on the west side of South America, there are actually 2 sets of mountains. There are mountains that are just off the coast, and those are all volcanic mountains. And then further in, there's a set of folded mountains. Okay, what's that? Absolutely. Absolutely and for sure. So in this one, I would draw a line like this. Okay, with my ocean. And then you've got your continental crust that comes up over. And again, it's a convergent boundary, so they're coming together. All right. And again, you have 2 different sets of mountains. This picture doesn't show it. The one that was in the book does, though. You've got a set of volcanic mountains from the magma coming up here. And then you've actually got a set of folded mountains that happen a little bit further in. So you could label these if you want. These ones are volcanic. The ones right next to the shore, or right next to the sea. And then these ones further in are folded mountains. Okay. The Andes Mountains in South America are formed You wrote this one down, the Nazca Plate. Do you remember that? We looked at that when we were looking at our big map. The Nazca Plate is the plate that's right next to South America, and the South American plate goes just over it, so the Nazca Plate subducts under the South American plate.
all that now?
You mean this part here?
Yeah.
You could just write the Andes Mountains. If you know where the Andes Mountains are. And if you don't, then I'd write Andes Mountains in South America. Yeah. I'm not going to give you a quiz question that says, like, where are the Andes Mountains, right? But I do want you to be aware if you're looking at a map, oh, I know where these are, and oh, this is where you have an oceanic crust meeting a continental crust, and we have a convergent boundary. How are we doing here, team? Are we good? More time? Are you good? Ready? All right. Number 3, anybody have a guess as to what the boundary type is going to be? It's going to be continental. Indeed, and it's going to be a plate interaction. I think this looks like oceanic, though. I'm going to look for a different picture real quick. Is that okay? It's okay.
It's a gift. So
No worries. No worries. Hold on. Continental.
I also have to play in the plate, though.
All right, let's do this one instead. Is that okay?
Yeah.
It's all good. We're learning.
It goes.
It's playing. No, wait.
What are you upset about?
No, watch it. It plays.
Oh, it plays?
Yeah.
What? You guys are technical.
Might want to erase your little drawing.
I'll erase my drawing. Just be patient. Okay, hold on. Let me view it. It plays.
That is raw.
That's pretty cute. Oh, it's not done. There's even more? But wait, there's more.
I know, we're researching positive.
It gets the chicken pox? No, I'm just kidding.
Cool.
Oh, cool. Warm hot. Oh, cute. This is pretty adorable, not gonna lie.
When I search content,
Okay. So that's pretty hilarious. Oh, there's more.
that's
You gotta let me. Oh, that's okay. I was gonna say, let me know when it's done. All right. So that's fabulous. I love the video. Now, question for you, and this I'm not trying to put you on the spot here, but I do want you. This is like a lesson in Google searching, right? So hold on. Stop looking at this because I want you to listen to me for just a minute here. Okay. I want you to listen. This is a lesson in Google searching. So you were doing continental, which means it's got to be land on both sides, right? Okay. So just because you type something into Google, does that mean that whatever comes out is right?
No.
It does not. And you want to know why that probably happened? It probably came up because there was also another picture below it or something, right? Like, and the tags got messed up. So I love that video. It was super adorable. But it was a video that should have been on which one?
Oceanic continent.
It should have been on Oceanic Continental. Does that make sense? So it was a nice animation of what happens, but for what we're going for, we really want a picture. So I'm going to put this picture over it. Oops, no, go back. Hold on. Spoiler alert. Ah. Okay, hold on. Where are we at? Was it this one? No. What did I do?
It's a third one. Someone must have put it on third.
Oh, you did? Thanks, Hannah. Gotcha. You're like, I just wanted to see it. Okay, here we go. So thanks to Hannah, it's all there now. So I just want to make sure that makes sense. So that's a good lesson in life, right? You're living in this digital world, but you have to be smart in order to do things right because you don't want embarrassing things to happen. So there you go for that. So let's take a look. Continental is a convergent plate boundary. It creates your folded mountains. This is what you saw in Sandbox Earth, right? This is exactly what you saw. This is like the mountains that came up, okay? The folded mountains come when the continental crust on one side and the continental crust on the other side come together. So you've got one side over here, one side over here. Right, these are your mountains. Does that make sense? Did you like my sound effects that go with that? They are folded mountains. The Tibetan Plateau is absolutely part of an example of continental plate interaction. Do you know what part or what mountain range the Tibetan Plateau is a part of? Anybody, geography friends? It's not the Andes. Good guess. It's the set of mountains where Mount Everest is.
I don't know. We haven't learned that yet.
The Himalayas. The Himalaya Mountains. Yep. Did you just say that? Yeah, say it louder. Yeah. So anyway, those are folded mountains. So if you may not remember from when we were doing the Pangea puzzle, but India is not really attached to Asia. It looks like they are now, but India is its own thing, and it ran into Asia, continental convergence, and that's exactly where the Himalayas are. Okay, because the Indian plate and it's not called the Asian plate, but you know what I'm talking about, right? That's where all of these mountains came from. Okay, we good with this one? Ready to move on? Who said no? Okay, keep going. It's okay. All right. Oceanic divergent. So this is oceanic again, but it's a little different. This is the one, my friends, that you have been most exposed to in this class so far. Okay? So in this case, again, this picture, I don't know if this is my favorite picture for this. Because we're talking about under the ocean, right? This is all stuff that should be underneath the ocean. I'm gonna just do a quick search again, okay? Is that okay? Here we go. I know. Oceanic. Hold on. Divergent. That's what I'm talking about right here. That's what I'm talking about. Let's throw that one in there. Oops, that wasn't what I wanted. Boop. Okay, so before I completely cover that up, let's talk about it here for just a second. Why did my reaction to this, why was it not super positive?
Because it's not underwater.
Not underwater, right? Oceanic means if you've got oceanic crust on both sides. So let's get ourselves some ocean on both sides. What kind of mountains occur when you have oceans on both sides?
Underwater.
And you have a divergent boundary? We've talked about this already. We talked about this last week on Friday. We were at our stations. Do you remember we did the toilet paper and what? Because that was a divergent boundary, right?
Isn't it like the new crust form?
Yeah, the seafloor spreading stuff. So even though the ocean crust is moving apart in this case, so you got ocean crust moving this way, you got ocean crust moving this way, what comes up in the middle between those two plates? Magma. And that magma makes mountains, right? That magma comes up. Underwater volcanoes make mountains, okay? The type of mountains are primarily ocean ridges, okay? The fault block mountains also are true. The Sierra Nevada block mountains, I believe, yes, are an example of this from a long time ago when we were underwater. Another great example of this would be the mid-ocean ridge. Right? That's another good example of this oceanic divergent plate interaction. And I was going to put this back on view mode so you can see it. Oops, now my picture's a little bit different. How are we doing on this one? We're doing okay? Ready to move on? All right, last one. Fantastic. Wait, what? You not ready? The Sierra Nevada block mountains is one. The other example is the mid-ocean ridge, right? All right. The non-boundary, so that's what? It's a boundary, but it's not a boundary. These are the mountains that are not created at a boundary between two pieces of crust, two plates, okay? They are mountains that are formed for other reasons. I mean, it's kind of a funny deal. Some of them are formed at volcanic hotspots, okay? One of our favorite, perhaps, examples of that are the Hawaiian Islands,
Yay.
right? The Hawaiian Islands, a lot of people want that to be at a place where two plates are meeting, but it's not. They're just hot spots where magma erupts out of the crust, okay? And it makes mountains, okay? Also the Southern Rocky Mountains, same deal, okay? These ones came from pushing together and some motion of the crust, but not two plates being pushed together.
So it's just like two plates like throwing against each other.
So it's not actually a boundary between two plates. So it's just a plate that has movement to it, or has some interaction because of magma from the mantle that's coming up. Does that make sense? That one's it's kind of like, let's catch all the other things that don't fit into our other sets of
How would we draw this?
You can draw.
I'm so excited.
I would just draw some Rocky Mountains and just not have any faults in there, and you'll be fine. Thank you guys so much for a great day. I really appreciate it. I will see you tomorrow. Be well.